Okay, hi everyone. So today is a new video that I'll be trying to solve another mathematical Olympia question. This time around is a question that involves, system equation. All right, so that's the equation that we'll be looking at today and tackling it. All right, so the question is, okay, you are given x plus y equals to 1, x to the power of 4 plus y to the power of 4 equals to 881. So you are asked to find what is x of y. All right. So in order to find this, just very quickly, I come back. Okay, I'm going to show you my solution. How am I going to do this? All right. So coming back, I'm going to share my PowerPoint. Okay, so I will just write down these system equations over here on my PowerPoint, and we are going to apply a technique. My method of solving this question is actually applying something called the Sophie Germain's identity. So what is Sophie Germain's identity? Now, the Sophie Germain's identity says that if you are given that a to the power of 4 plus, 4 of b of power of 4 is equals to the following product. A squared plus 2b squared minus 2ab product with a squared plus 2b squared plus 2ab. Okay, and that is something that we are going to apply as a strategy to solve today's question. Okay, so anyway, that's known as Sophie Germain's identity. Okay, so now I'm going to write the two system equations over here. I label it as equation 1 and equation 2. Now from equation 1, I'm going to square both sides of the equation. So x plus y squared equals to 1 squared. Thus, I write out the expansion. It gives you x squared plus y squared plus 2xy equals to 1. All right, so now I'm going to rearrange the terms by putting x squared plus y squared on the left and 1 minus 2xy on the right. Okay, thus I label this as my equation 3. Now we are going to take a look at equation 2. And equation 2, remember, we are going to apply the Sophie Germain's identity to solve this question. So I'm going to apply the identity into equation 2, thus transform this, into what we saw earlier. So I'm actually getting, x to the power of 4 is x to the power of 4. Okay, and I'm going to rewrite y to the power of 4 as 4 multiplied by y over root of 2 to the power of 4. Because root of 2 to the power of 4 basically gives you 4, and 4 can cancel out, and it gives us back the same thing. It yields back the same y to the power of 4. Okay, 881, I put it here. So now I actually transform at these two steps. I actually transform equation 1 and equation 2 into what we have here, equation 3 and equation 4. Okay, so now we are going to look at equation 4. Notice that the left-hand side, reminds us of the Sophie Germain's identity. So I'm going to write out the identity. The left-hand side becomes, x to the power 2 plus 2y to the power 2 over 2 minus 2x of y over root of 2, of the product of, x squared, all right, x squared plus 2y to the power 2 over 2 plus 2x of y over root of 2 equals to 881. Okay, so this is basically this entire chunk is just the Sophie Germain's identity from equation 4. Thus, now if we're going to simplify the terms, very simple, x squared you have here, y to the power 2 or y squared is over here because 2 and 2, you can just cancel them off. Okay, and over here, 2 and root of 2, it gives us root of 2 on top of x and y. All right, so over here will be x squared, plus y squared. This is the y squared plus root of 2 x of y. Which is equal to 881. Now the next step, we are going to apply what we have in equation 3. We are going to substitute equation 3 over here into this part here. Now notice we just now have put x squared plus y squared on the left. So in this case, I'm going to substitute the x squared and y squared over here and over here, as 1 minus 2xy respectively. Notice I actually replace them. Thus, for root of 2x of y, I remain. I do not change it. Okay? Which is equal to 881. Now, at this point, I'm going to look at an expansion. I'm going to expand out this expression on the left-hand side. If I expand it out, what do I get? Now, basically, we have an equation. In this case, we just look at these two terms. For example, these two terms I can put as 2 plus root of 2 x of y. All right. And over here, I can have minus 2 minus root of 2 x of y. Okay, I hope you can see I just add in a bracket. Okay, so I just add in the bracket. And now I'm going to expand, okay, these terms. I'm going to multiply all these terms together. Thus, what do I get? Okay, 1, I have 1. 1 multiplied by 1 is 1. Okay, and 1 multiplied by negative 2 minus root of 2x of y is minus, over here, 2 minus root of 2 of x of y. Okay, so over here I multiply again, it will be minus 2 plus root of 2 x of y, because multiplied by 1, it is itself. Okay, and there's a negative sign over here. Okay, so after that, what's going to happen? Now, over here, I'm going to look at the terms a bit more. Now, over here, I have basically this term multiplied by this term over here. So 2 plus root of 2, 2 minus root of 2. Okay, now we have x and y, which is x and y squared. Okay, which is equal to 881. All right, so now we are going to look very carefully. Now I'm going to, okay, remove 1, okay, on both sides. So if I remove 1 minus 1 on both sides, I have 880 now. Now on the left-hand side, notice, okay, if I'm going to combine, if I'm going to group these two terms together, what's going to happen? So if I'm going to group them together, I basically have, all right, 2 minus root of 2, okay, and over here, 2 plus root of 2, okay, and we have the minus sign, we just bring it out, okay, so we just bring out the minus sign, okay, and in this case, you have a negative, because the minus sign, we bring it out. 2, okay, so 2 plus 2, which is 4, okay, minus root of 2 plus 2, which is 0. So over here, we have minus 4x of y. And over here, based on the difference of two squares, all right, 2 plus root of 2, 2 minus root of 2. It gives you 2 square minus root of 2 square, which is 4 minus 2, which is 2. Okay, x of y squared, which is equals to 880 now. Okay, because we are just subtract 1 on both sides. Okay, so that's why over here it's only 880. Now, I'm going to factor out 2. Okay, and I'm going to divide both sides by 2. Okay, and what's going to happen? So I divide by both sides. I have 2x of y, minus 2x of y, xy of square. All right, and 440 now, because it's divided by 2 now. And I bring it over to the left-hand side, I get minus 440, which is equals to 0. Thus, notice in terms of x and y, I actually form a quadratic equation. So I can just very simply solve this quadratic equation, okay, by plunging in all the terms into the quadratic formula. Thus, I obtain x of y, okay, equals to either 22 or negative 20. All right, and those are the answer. All right, for this problem. So the answer for x and y, they are 22 or minus 20. All right, so now we are going to go back and let's take a look at what others have to say. Okay, let's see what they comment. All right, so going back, okay, we just take a quick look. Okay, I actually commented, I say I applied the Sophie Germain identity to solve this question. Okay, and that's what I got. Yep, for example, over here, there's another person who also got 22 and minus 20. All right, I think, I'm not sure, I think he applied the binomial theorem, but okay, anyway, I believe everyone has their own way of solving. All right, yeah, another person also minus 20 and 22. All right, and okay. All right, so over here, I believe some of you got also the same thing. Okay, but this one, no. Okay, maybe. All right. So basically, I can say that there are two solutions to this. All right. XY is 22 or 20. All right. So thank you very much for watching and hope that you have a nice day ahead. All right. Thank you. Goodbye.